Cloud migration is not just a location change. Moving hardware from your data center to someone else's building is the easy part. The real change is the operating model. APIs, automation, managed services, and a shared responsibility model. Welcome to Road to Architect, Learning the Cloud as I Go. This channel is for people who want to understand Azure and Enterprise Cloud the way architects and SRE-minded teams actually work, decisions, trade-offs, and real-world constraints. In today's video, data center to colocation to cloud, I'm going to break down what actually changes as organizations move along that path and why lift and shift often disappoints. We'll look at this through three lenses: enterprise architecture decisions, DevOps execution, and FinOps cost reality. If you're searching for things like colocation versus cloud, data center to cloud migration strategy, or why lift and shift fails, you're in the right place. Quick note, this is educational content, not vendor-specific consulting advice. Now let's start where most enterprises begin, the traditional data center. On the next slide, let's define why the data center model hits a wall, especially when speed and scale become the business requirement. Traditional data centers can be excellent when demand is stable and change is slow. If your application portfolio is predictable, your capacity planning cycles are mature, and your release cadence is measured, on-prem can run efficiently. But enterprises hit a wall when they need rapid growth, frequent releases, global scale, or simply faster time to market. Here's what typically breaks first. Capacity is fixed. You buy for peak demand, then you carry idle capacity the rest of the year. Provisioning is slow. Tickets, approvals, hardware lead times, and dependency chains turn a "we need it next week" into maybe next quarter. Resilience is expensive. Multi-site DR, replication, test cycles, and operational readiness become big projects rather than routine capabilities. And operations become manual by default. Drift accumulates, servers become snowflakes, and knowledge becomes tribal. And financially, cost is CapEx heavy and hard to allocate per product team. Many orgs can't clearly answer which app is consuming how much infrastructure and operational effort. So the bottleneck isn't only technology, it's the model. The data center operating model is optimized for ownership and control, but it struggles with speed, elasticity, and repeatability. So, what do many companies do as the first step? They move to a better facility. That's where colocation comes in. Colocation is often the first migration step because it solves a real problem, the facility layer. In a colo, you typically get improvements like better power, cooling, physical security, and sometimes better network options and connectivity. You reduce facility management overhead and gain flexibility on space. But this is the key point, and it's worth saying plainly for anyone researching colocation versus cloud. Colo is not cloud. Colo improves facilities, but it does not change the IT operating model. You still own and buy the servers, patch and maintain operating systems, manage backups, do capacity planning, design and test DR, and provision through ticket-driven workflows. So colo can be a smart move, especially for data center exits, lease expirations, or upgrading physical resiliency. But you shouldn't expect colo to deliver the core benefits people associate with cloud: elasticity, API-driven automation, and managed services. Now let's move from better building to a different operating model. This is the real turning point. Cloud is the turning point because it changes how IT is built and operated. First, capacity becomes elastic. You can scale up and down, ideally matching demand. Second, infrastructure becomes API-driven. In cloud, repeatable automation isn't a nice-to-have, it's expected. Everything from networks to compute to policy can be declared, deployed, and validated. Third, managed services reduce undifferentiated operations. That means less time patching, more time designing reliable systems. But that doesn't mean no responsibility, because in Azure or any major cloud, you still operate under a shared responsibility model. The provider secures the cloud, but you secure what you put in it: configuration, access control, identity, and data. And here's a practical truth.
Cloud speed is only safe when guardrails exist: identity standards, policy baselines, network design patterns, and operational monitoring. So if you skip guardrails, cloud becomes fast chaos. If you build guardrails, cloud becomes fast and controlled. So what exactly changes when you move to cloud? Let's break it into 6 domains that architects and platform teams must treat as one system. This slide is the real-world checklist view. Cloud impacts 6 domains at once. 1. Security becomes identity first. It's less about perimeter firewalls and more about identity, least privilege, and continuous verification. Policy guardrails become mandatory, not optional. 2. Networking becomes architecture. You're designing segmentation, exit paths, private access patterns, and connectivity as a first-class engineering domain, often with hub and spoke patterns, private endpoints, and very intentional traffic flows. 3. Delivery becomes automation-led. Infrastructure as code plus CI/CD becomes the standard. Instead of building environments by clicking, you declare environments and deploy them consistently. 4. Operations becomes observability-led. Logs, metrics, traces, alerts, SLO signals, these aren't add-ons, they are baseline requirements, with runbooks and incident response built into the operating model. 5. Resilience and DR become design choices. Cloud gives you options, regions, zones, managed HA patterns, but you still have to decide and test. DR is not enabled, it's engineered and validated. And 6. Cost model becomes variable. That's powerful when controlled and punishing when unmanaged. Cloud introduces unit economics, cost per product, per environment, per customer, per transaction. So if you want practical Azure skills that translate to enterprise work, this is the mindset. Cloud is not a single migration project, it's a multi-domain operating model shift. With that in mind, we can explain why so many early cloud migrations feel disappointing, especially when the approach is lift and shift. Lift and shift, also called rehost, is a common first wave, and sometimes it's necessary, but it often disappoints when people expect it to deliver cloud value immediately. Here's why. If you copy data center sizing into cloud, you over-provision and you pay for always-on capacity. If you keep manual operations, you create drift, config changes outside a controlled pipeline, leading to outages and slow recovery. If you ignore network exit and logging growth, you get surprise bills, and the finance team loses trust quickly. And if you skip managed service benefits, you still do the same operational work, just pay more for the platform underneath. This is the key idea. Cloud rewards automation and right sizing, and it punishes same as data center but rented. So lift and shift is not the destination. It's a first wave for speed or urgency, followed by deliberate modernization. So what does a realistic modernization strategy look like for enterprises? It looks like waves, portfolio thinking, not a single massive refactor. Here's the modernization ladder. 3 waves that most mature programs use. Wave 1, rehost. Goal, speed, minimal change. Great for exiting a data center quickly or reducing facility risk. But watch the downside. Costs and operations can be worse if you don't follow with optimization. Wave 2, replatform. Goal, quick wins. You adopt managed runtimes or platform services with limited code changes, reducing operational load. You're not rewriting the app, but you are changing how it runs. Wave 3, refactor. Goal, cloud-native outcomes, scalability, resilience, and improved unit economics. And this is portfolio thinking. Not everything deserves refactoring, and not everything should remain a VM forever. Now let's talk execution. Cloud success isn't just architecture diagrams, it's the delivery system. That's where DevOps changes the game. In cloud, repeatability is the product. DevOps shifts from ticket-driven provisioning to pipeline-driven environments. That means you define infrastructure as code, Bicep or Terraform, so environments aren't click-only. You implement CI/CD gates, validate, preview, or plan, then deploy, then post-deploy checks. You standardize environments, dev, test, prod, using parameters and policy baselines rather than reinventing each environment. And you treat monitoring as part of deployment. Diagnostics and alerts are defaults, not afterthoughts. From an enterprise architect viewpoint, this is huge. The platform becomes consistent, auditable, and scalable across teams. But none of this works long-term if cost is treated as finance's problem. In cloud, cost must become an engineering signal. That's the FinOps shift. Financially, cloud isn't automatically cheaper. It's more measurable and more controllable if you operate it with discipline. Cloud spend is variable, so you need two things: ownership, who pays, and allocation, how do we attribute spend. Consistent tagging is not nice, it is governance. Common cost drivers during migration include always-on compute, storage growth, exit, and logging ingestion.
The control loop looks like this: budgets and alerts, then right size, then autoscale, then apply discount levers like reservations for stable usage. And here's the line every enterprise eventually learns: if you cannot attribute cost to a team or product, you cannot control it. That's why FinOps is not just a finance framework, it's a cloud engineering capability. Now let's wrap Part A with a clean summary, and then I'll set up Part B where we talk about the hybrid model most enterprises actually live with. Let's close Part A with one core idea. Colocation changes the facility. Cloud changes the operating model. Lift and shift can be a fast first wave, but real cloud value comes from modernization plus guardrails across security, networking, delivery, operations, resilience, and cost. In the next video, Part B, we'll cover hybrid reality, why most enterprises run data center and cloud together for years, and how to design that bridge intentionally: connectivity, identity, governance, and operational consistency. If you found this useful, subscribe to Road to Architect. This is part of the step-by-step series, and we're learning the cloud as I go from zero to enterprise architect. And if you want, drop a comment with where your org is today: data center, colo, cloud, or hybrid, and what's blocking the next step. All right, see you in Part B.